Hey guys, on to my third problem that popped up on Excel when I started this guy. Obviously the first two I got correct, so this is what they spun up the next time. When I did finish this one, I did end up with a 50, so not an 80 yet, but getting real darn close. This is a little more work. I would say probably the hardest part about this is you actually have to think a lot. And there's a couple different ways to go about getting these puppies done. But cosecant and cotangent. So cosecant, I'll try to walk you through my thought process without making it too confusing, is sine theta. Cosecant is sine theta. Cotangent is cosine theta over sine theta. In my mind, I like Pythagorean identity the best. So if I have cosine and sine, that's where I'd like to be. So you can do this way, the math this way, but also, and that would be, so at that rate, we would do cosecant is 5 over 4 equals 1 over sine theta. You would cross multiply, which would give me sine theta 5 times 5 equals 4, because 4 times 1 is 4. We need to get rid of that 5 because we want it to be sine theta equals. So sine theta equals 4 over 5. Now that's a super mathy way to do it. You can also do sine theta. When you're looking at your list, it's a lot easier to see all these. So just know that I was looking at the list as well. So sine theta is 1 over cosecant theta. That's the rule. So this is one rule that you could choose from. This is the other rule you could also choose. Because we're given the cosecant, so that would mean sine theta is 1 over 5 over 4. You can't leave a fraction in the denominator, so we're going to flip that. It's going to be times 4 over 5, which will make these guys go away, and then 1 times, so again, we're back to that 4 over 5. Both of those are correct to get there. Whichever one you chose and whichever math makes sense to you, fine. But sine theta is now 4 over 5. So get over here, I have 4 over 5 in the denominator, which is not ideal, but now I'm missing cosine. So if I have sine and I'm missing cosine, that's like in the last one I had these highlighted, sine and cosine, hopefully as soon as you see those two, you think you're Pythagorean identities. And remember, whichever one we need cosine at this point. So it's going to be cosine squared theta equals 1 minus sine squared theta. So we're going to do cosine squared theta is equal to 1 minus, we know our sine is 4 over 5, and we want to square it. Again, go put this half directly into Desmos, and it will give you a decimal if you don't hit the circle with the 2 boxes to the side, and we definitely want that fraction. So move it to a fraction from that decimal. Then from here, we're going to get 9 over 25. This is cosine squared. We want cosine plane, just as itself, as a singular. So we're going to square root both sides. Again, these are nice, neat ones like I was telling you in the last video. Those guys both give you a beautiful square root. So the square root of 9 is 3. The square root of 25 is 5. Remember, every time you take the square root of any number, you have a positive and a negative. In this case, we are in quadrant 1, so it is always going to be positive. So then cosine 3 over 5 is going to go up here. Obviously, hopefully by math 4, we know cosine that we can't leave, fraction and a fraction within a fraction. That's a mess. But to get the fraction out of the denominator, we're going to multiply by the reciprocal. And ultimately, you're doing it to the top and the bottom. These guys cancel each other out. So now we're doing 3 times 5, 15. 5 times 4 is 20. We are in math 4. Do not leave unreduced fractions. If you need to use Desmos to do that, that's fine. So you would type in that 15 divided by 20 and then hit the circle with the 2 boxes on the left-hand side. And they both are divisible by 5, so it should be 3 over 4. And in that case, we have 3 over 4. Cotangent is this ratio, 3 over 4. That's what we're solving for. We're in quadrant 1, so it definitely is positive, and that guy is done. So you had to use multiple rules. So ultimately, at least 2 of them. Again, I did it both ways in case your brain just happened to go down a rabbit hole different than mine the first hit. Both are correct. So after I finished this third one, I was sitting at a 50 in IXL. Again, slow down, do the math, write it down, and you will be much happier not having to do so many problems. The fourth problem they gave me again was a cosine and a sine. Don't panic because it says a square root on the top, because you do have Desmos. You don't have to even know what it means. But to the conversation, When you square something, it just gets rid of the square root anyway. It undoes it. So this would be 3 over 9. So 1 minus 3 over 9. And then they would reduce that to 1 over 3. 1 minus 1 over 3 is going to leave me 2 over 3. Just for the mathy reason, but again, you do have Desmos. Sine squared, so we're going to square root both. Now, I stopped writing prior to us talking here because this is where I talked about you have to rationalize the denominator. You can't have a fraction in the denominator. So, a square root in the denominator. So we're going to multiply by the square root of 3 and multiply by the square root of 3. Square root of 3 times the square root of 3. The long math on that is the square root of 9. And we know the square root of 9 is 3. So once you square the square root, that again is the inverse and just gets rid of it. So I now have a 3 in the denominator. Square root of 2 times the square root of 3 is going to be the square root of 6. 6 cannot be simplified by any better number to give us, 4 doesn't go in there. 4 times something does not give me 6, so I can't pull out anything nice and neat. So our answer is going to be just that, the square root of 6 over 3. And that is sine in the quadrant 1. And we have our answer for that guy too. And guys, that should get you pretty close to a 60. If not, holler if you need more help. Obviously, we have tutoring from 12:15 to 1:15 every day. And we also have live class on Friday. At this point, it's not late until Sunday. So if you need help, come find me.